The next test that we're going to do is the ratio test, and this is maybe the most important test of all the ones that we've looked at. So for the ratio test, you're going to start with a series, the same series that we've been working with. So from k equals 1 to infinity of a sub k, we're looking at non-zero terms. Then look at the ratio. So we're going to look at the ratio limit as k approaches infinity of the absolute value of a k plus 1 divided by a sub k, and figure out what that limit is. And then three things can happen. If L is less than 1, that means that your series converges. If L is greater than 1, it diverges. And then if L is equal to 1, then the test fails, you need to do something else. It doesn't mean that the series converges or diverges. That just means that you do something else. So for the ratio test, you're going to look at the ratio of a sub k plus 1, so the next term, divided by the previous term, and see what that ratio is. This test is really good if you have factorials. So if you see factorials in your series, I would automatically go to the ratio test. It's also good if you have a lot of powers and then non-power terms. Got a couple. The first one I'm going to do is I'm going to do k over 4 to the k. So this is what I mean by powers and non-power terms. I have this 4 to the k, which is kind of like a power term. Then I have this k that's not a power term. So let's use the ratio test. So the ratio test says the limit as k approaches infinity of the absolute value of a sub k plus 1, a sub k. So what that means, a sub k plus 1, that means everywhere you see a k in my series, I'm going to replace it with a k plus 1. So k plus 1 divided by 4 to the k plus 1. Then I'm just going to divide this by my a sub k. Now I'm dividing by a fraction, which means that I'm going to flip it and multiply straight across. So I have k plus 1 divided by 4 to the k plus 1, and then times 4 to the k over k. Now let's see what happens. I have a 4 to the k on the top and then a 4 to the k plus 1 on the bottom. So I think all those are going to go away, which just leaves me with a 4 on the bottom. Then, since you're going towards infinity, only the highest power terms matter, so get rid of this 1, and I'm left with 1/4. So 1/4 is less than 1. What does that mean in terms of converging and diverging? Or if the ratio is less than 1, that means that it converges. So I looked at the ratio, simplified it down as much as I could, and that gave me that it converges. Next, I'm going to look at the series from k equals 1 to infinity of 5 over k factorial. And when you see factorials, automatically go to the ratio test. So my ratio test is the limit as k approaches infinity of the absolute value of a sub k plus 1 over a sub k. Nothing in this problem is negative, so I don't really have to worry about the absolute values here. So a sub k plus 1, that means everywhere you see a k up there, replace it with a k plus 1. Then I'm dividing that by just everywhere you see a k, leave a k. Kind of messy there. I'm going to flip that bottom part, multiply straight across. So it looks like I get 5 over k plus 1 factorial times k factorial over 5. My 5's are going to cancel. So I get k factorial over k plus 1 factorial. And now we need to simplify factorials, which we've done a little bit before, but this is something like, what is 5 factorial over 6 factorial? So k over k plus 1. Well, that just gives me 1/6. You can actually write out the terms and see that. So I get the limit as k approaches infinity of 1 over k plus 1. And as k approaches infinity, this entire thing goes to 0. 0 is less than 1, which is good. So that means that my original series converges. We want to look at one more here. Let's look at the series from k equals 1 to infinity of 8k plus 5 over k to the third. And let's look at the ratio test and see what happens. So the limit as k approaches infinity of 8k plus 1 plus 5 over k plus 1 cubed divided by 8k plus 5 over k cubed. So I'm going to do the same thing we've been doing. Take the bottom, flip it, multiply straight across. So I get 8 times k plus 1 plus 5 over k plus 1 cubed times k cubed over 8k plus 5. Because we're looking at infinity, you only need to look at the highest power terms. So the highest power terms are going to be that 8k, that k cubed, and on the bottom, that k cubed and that 8k. But if I look at that, I get a 1, which means that the ratio test failed. Now the thing is, just because it failed doesn't mean you skipped the problem. It means you try something else. Now if it were me and I saw this problem, I would say, well, maybe the ratio test wasn't that good. Maybe I should use a limit comparison test and compare it to the p-series 1 over k squared. And the reason I'm choosing that is because 8k over k cubed in the long run eventually kind of looks like 8 over k squared. So I'm going to compare it to 1 over k squared. If you do that, you're going to see that they're the same. It converges by the limit comparison test. So actually do this out. You're going to see that this converges by the limit comparison test with the series k equals 1 to infinity of 1 over k squared.